Hi everyone, welcome and thanks for coming to the third installment of our presentation series on using R. Today's topic, reproducible research, won't be about using R per se, but it's going to be about how you can leverage some of those data science tools to share your R code. And like previous presentations, everyone is muted by default, but feel free to ask questions along the way in the chat and note the slide number in your question if you think it's going to help. I'll try to answer questions at the end of this. So the first half of today's presentation is going to be an intro to some of the topics you see listed up here: reproducible research, RStudio, Git, and GitHub. And the remaining portion of the presentation is going to be kind of an interactive tutorial, and I'll be going back and forth between slides and using RStudio. So let's see, there we go. So the introductory topics, like I said, we're going to talk about reproducible research and kind of the best practices within that realm. I'm going to do an overview of Git and GitHub and the role that they can play in reproducible research. And then finally, I'll show you how you can integrate both reproducible research and the GitHub toolset with the RStudio interactive development environment, which has come up in previous presentations. So first, we're going to cover reproducible research. So when we want to discuss what reproducible research is and why it's important and how you can do it, I think the really important parent idea or progenitor behind reproducible research is actually this notion of the replicability of research. In an ideal world, the results of any sort of research study you conduct or that someone else has done would be totally independent from the location of the study, the investigator, the specific data set that's been collected, instruments used, and anything else that was specific to one single project in order to draw its conclusions and come up with ascertain whether or not the hypotheses of a research study were true or false or whatever the aims were. But instead, anyone anywhere in the world should be able to get the same results, and any study conducted could, in theory, be perfectly replicated somewhere else at any time. Of course, there's a lot of assumptions here, and it's very much an ideal world scenario, but it is kind of what like a gold standard situation would be, is that your research is entirely replicable. Of course, there are quite a few limitations to that, most of them revolving around money. It can be wasteful to run studies that aim to prove a point that's already been proven. And I think that a lot of people here recognize the fact that non-novel work is just not likely to be funded. So there's not much room to really do replication studies. So given the limitations of actually replicating studies, I think the best compromise that people have come to is this notion of reproducibility. And in reproducibility, the main idea, the main thoughts are that your data and the code and everything else you generate through the process of running your study should be made available to others. So what are some of the incentives? Why would you want to actually engage in reproducible research? At the top of your list should just be the fact that it makes you compliant with many data and code sharing requirements and general open access guidelines. So some of the top journals that you are familiar with, like Nature and Science, require that you make data and code accessible to the public. And per the UCSF library, it's likely that the NIH is going to have a comprehensive data sharing mandate by the end of 2021, with which the entire MAC will need to be compliant. So if, for example, you want to publish in Nature Neuroscience, you'll be required to attest that you will make your code, your data, and all the other methods that you've used to publish a paper available to other researchers. So people are already getting out ahead of this by hosting their code and methods in places online so that they don't actually have to field requests directly. And I would really say that at this point, data and code sharing requirements they're not just the future, they are already here. And I think that if you're not up to speed on them, that people will fall behind, and it's going to be problematic going forward. So one of the greatest benefits of sharing your code beyond just being compliant with requirements from different funding agencies and publishers is that publishing your analyses both makes them transparent, which inherently adds a level of trust, and you can disseminate the tools and the analyses that you've done more readily. I think that in an ideal situation, this will lead to more citations of your work and more citations of your methods. And moreover, spreading your methods can more quickly advance the work within your field and beyond. So I presume that everyone here today is part of dementia research because they want to help further potential treatments for dementia. And I think that doing that in the most expedient way possible is definitely something that we can all look forward to. And then finally, this is more of something that's a little bit smaller scale, I would say, but following the methods that people use for reproducible research can, in a lot of ways, make it easier to go back and reference and look at your own previous works. When you have everything neatly organized and published, when you have your code and your data neatly created and prepped to go out to other people, it means that if you want to go back and look at your work that you did in the past, it's going to be much easier for you to understand, because I know that there's code that I write and data cleaning that I do that 6 months later, I will not remember what I did, but if everything is clearly written out with readable functions and documentation, I can look back at any point and understand what I've done in the past. So that's one of the biggest benefits, I think, from a personal perspective. So when thinking about how you can be compliant with reproducible research, there are really two key components to what you would need to do. The first is just making sure that your raw data, the data that's been collected, MRIs, neuropsych data, is in some way available to other researchers. And there's a lot of work that goes into making data sets that are shareable with others in kind of a de-identified way, or making sure that whomever it's being shared with has the training and the ability to handle identifiable data. The other main component is that you provide the full set of instructions to go from the raw data to the final product. And in this case, the final product being the paper that you've published, or some sort of method or analysis that you want to get out there. People need to be able to see and verify all of the steps that you've taken to get to your final product. So there are a lot of logistic considerations that go into making your research reproducible. At the top of that list, the code that you write should be readable to others and your future self, as I had mentioned on the previous slide. And you should be using well-established analysis libraries, so not using proprietary software solutions that aren't going to be transparent to the rest of the public. And then just adhering to any sort of established data sharing policies. And I know that the UCSF and MAC have some existing policies about how to share data. And other meta info that you might want to include when trying to help people reproduce the research you've done is sort of stuff about what sort of computer system you're running, maybe random number seeds if you're using noise or stochastic analyses, and just other program minutia. And a topic that I'm not going to go into detail today about is what's called literate programming. And it's essentially the kind of the logical conclusion of the conceptual endpoint to reproducible research, where all of your code and your data are integrated to one final product. So in literate programming, everything you write will exist within a single document. And what I mean by that is that all of the code you write, all of the output from that code, and everything that you're documenting about your code, all of the comments, if you want to describe the methods, the participants, the analyses that you did, and a discussion. If you were to, in effect, write an entire paper in a single document, that's what we would refer to as literate programming. So a simple example of this would be, if we were to say we have two parts. We have an Excel file and a document, such as an R Markdown file. And in the Excel file, you just have your data. And in the document, the R Markdown file, you would write and execute your code and interweave any sort of commentary on the output of that code. And that would be a literate document. And that's something that people should strive for. I know it's a lofty goal, but it is kind of like I said, the logical endpoint of reproducible research. So the UCSF and the MAC already have or are developing broader data sharing initiatives. So what I really want to discuss today is how you can go about making your code reproducible and available to others. So I've mentioned this point already, but I really want to harp on the idea that in order to make your research reproducible, every single step needed to go from your raw original data set should be done as reproducible code. So the libraries and packages you use, the analysis you perform, the code used to make your graphs, everything should be written out as code. And moreover, your data cleaning should be done using code. 100% of the time. And I know that people love to use Excel to clean their data because it's pretty easy to use the filtering functions. You can play with your data there. And I encourage the use of Excel to, play with your data, get a sense of what's going on there, maybe quickly spot check for some missing values. But if you clean your data and actually remove values directly in an Excel file, you're not going to know what you did 6 months from now. Even if you write down notes, it's likely that there will be some sorts of confusion. So I beg you to please do your best to try and clean your code using, clean your data sets using code as well. And I know this takes time, but it really will pay off. And you'll quickly find that it's easier to code your data cleaning solutions than it is to manually pick through Excel files. So when it comes to actually sharing your code projects, the GitHub website is definitely the most common and best place for getting this done. So with that, let's do a quick discussion of Git and GitHub. So what is Git? It's a version control system, and you can download it for free on the internet. And basically a version control system allows you to, it's a program that allows you to track changes in files rather than just save the most recent version of the file. So a good example of this would be saving a Word document. Anytime you go into a Word document, type some new lines, maybe delete a few chunks of paragraphs that you've written previously, and you save that document. And that newly saved version is the only version of the document you have. Everything you've done in the past is now gone or overwritten in some way. So I think that most people are probably familiar with Box at this point, and it lets you kind of track changes in your files over time. The major difference I would say that exists between Box and Git is that Git really lets you specify like whole directories or folders and files to track in your computer. And it'll only track it when you want it to track it. Whereas Box, anytime you save, it'll make a new version. And all of a sudden you have 58 different versions of the same file, which is not very useful to do in practice or to search through in practice. So in order to use Git, once you download it, there are really two major ways you can interface with this software. If you know how to use a shell language like Bash, you can do it through the command line or terminal, but I think that most people aren't very familiar with that kind of stuff. I'm not super comfortable interfacing with Git in my terminal. So what I turn to is RStudio. Some people have told me about SourceTree as another alternative software, and there might be some other solutions out there. But what these latter solutions allow you to do is just have a nice user interface to kind of use Git. And we'll get into a discussion and a little bit more of an overview about what Git actually looks like and some of the actions you can take later on in this presentation. What I want to talk about now is the counterpart or the online counterpart to Git, which is GitHub. And it's basically will let you track, anything that you track in a Git repository is going to be monitored the same way through a GitHub website. But it provides a nice kind of online user interface and an opportunity to write a little document that describes what the project is about that you're working on. And so GitHub is totally free. It lets you host repositories or projects. They can be either public or private, which I know will be of concern to people who maybe are going to be working on a project that they don't want others to view publicly yet. And just because this comes up sometimes, I do want to make it clear that code that goes onto GitHub is still owned by you. It's not owned by GitHub or anyone else. And we'll get into more details, like I said, about kind of what Git and GitHub look like when we get to the integration, which is going to be this next step that we're talking about, which is integrating Git and GitHub with RStudio. So for those of you who haven't been at my previous presentations, I just want to do a quick overview of what RStudio is. It's an interactive development environment for R, which is basically just a software that makes reading, writing, and running your code and coding projects much easier to do. And if you're going to be writing code in R, you're going to want to use RStudio. So RStudio supports a variety of languages in case you have projects that involve more than just using R. It supports the use of R, SQL, Python, Bash, and a couple of other languages on top of that. So it's a good kind of one-stop shop for any sort of coding projects. And another key aspect of RStudio is that you can create what are called projects, which are places to create and manage full um, full directories of files all together in one single bundle, I guess you could say. So we're going to talk a little bit more about RStudio projects. Like I said, they're pretty much a high-level way to organize something you're working on, either code-related or not. They allow you to divide workspaces for separate projects so that every project you work on has automatic and distinct working directories, source documents, a coding history, and so on. And so RStudio projects are designed to work with Git version control right out of the box. This comes pre-built with a nice user interface that I'll show you. And you won't need to know how to use any shell commands for all the major things you'll do because it can all be done using RStudio's user interface. And RStudio's projects let you easily view and track all items in your project inventory. So that include any sort of file type. It doesn't matter if it's an R, Python, JavaScript coding file that you've written, or if it's an Excel file, or if it's a Word document. Anything that's within your RStudio project is going to be going to be part of the project, more or less. And you, if you're tracking these with Git, you won't lose any sort of the older or iterative versions of work that you've been working on. So I'm going to bounce over to RStudio and show you what the viewer pane looks like when things are being tracked. So here's the procedure for starting a new RStudio project. You go to File, New Project, and then you want to open a new directory. I always start with just naming it, just whatever is going to be most relevant to the project, and let this run through. So you'll see that doing this has created a new directory. In this case, I put this kind of test folder on my desktop. So if I were to remove some of these programs out of the way, you'd see a new folder that's labeled for test project on my desktop. And yeah, so this space that you're looking at right here is what RStudio looks like when it's opened. And where I have my mouse hovered over is the directory that I've created. So if there are any sort of files that I save, they'll all go into this space. And we'll get into some more detail, and you see this in action in some of the later slides. But this has been a quick overview of the basic introductory topics. And I want to start this, kind of this demonstration tutorial on tying all of these together. I'll say now that there are a good number of steps to complete in this tutorial. And if you're watching live, then it might be a bit difficult to perform some of the tasks in real time. So I'll try and add some pauses every now and then, just so that if anyone's trying to follow along live, that they get a chance to complete the processes. And if you're watching this in a recorded version, then obviously you can just stop and play as you see fit. So in order to get started, there are a couple of downloads that you would need. The major ones, of course, being Git and RStudio downloaded to your computer, a couple of R packages, and then a GitHub account. So I've included information on downloading or getting set up with each of these in this set of slides. So if you want to download Git, there's a link for Windows and OS X. And if you happen to be running something that's Linux-based, there's a set of commands that you can run there that will download Git for you. And you can also either look up RStudio download or just go to the link on this slide. There's also a number of R packages that you'll want to download. These are the commands that you would want to run in an RStudio environment to download them. You'll see that the names are DevTools, Use This, and Keyring R. Again, these are in my slides on my GitHub, so if you want to reference them later, you can do that there. And then finally, signing up for a GitHub account is as simple as going to their website. So with that, assuming you have things downloaded already, we'll want to get into how you can get Git and GitHub set up. So the first step, like I mentioned, is that you can associate an RStudio project with a Git repository, either after you've created the repository or at the time you create it. So I recommend creating a project and Git repository together at the same time. And as a general best practice tip, you should aim to create an RStudio project anytime you start doing a new analysis project or maybe a data cleaning project, just so that everything stays neatly organized from the get-go. And when creating a new project in Git repo, make sure to check the create with Git repo option. Like I said, it's just easier to do it that way. And it's really just as simple as that to kind of get started with an RStudio project and a Git repo, which will track everything that you've done. If you happen to forget to initialize your project with Git, then you can follow the commands that are listed down here to basically associate a new Git repository. So let's go ahead and see an example of how you would start a project with a Git repo at the same time. So in this case, we'll go through the process we did in the earlier video, creating a new project in a new directory. And again, you'll need to name the project, and you'll see that, again, I've identified that I want to make this directory in my desktop, and there's a create Git repository button. And I like to open things in a new session, which was what that last button click was. And so with that, you'll see that we've created a project this time, but there are two additional files down in that bottom right file pane, a gitignore and an RHistory file. And if you happen to forget, like I said, to associate a Git repo with your project at the same time, you can go through the process that you see on the screen now, which was going through tools and then project options, and then going down to the git/svn section. And there will be an option to basically switch over from not having a Git repo to having a Git repo. So once you've associated a Git repo or created one alongside your RStudio project, you'll basically want to make and track commits. So what that means is that it allows you to save or commit any or all updated files. And what I mean by this is that you commit changed files piecemeal. You can wait to commit changes in a document until you reach certain milestones, if that's how you'd like to organize things. Or you can just say, hey, I've been working on a project for 5, 6, 7 days. Let me go ahead and commit all of my changes to a new update. So when you do this, Git will track it, will pay attention to all the changes that you've made, and it'll allow you to review your commit history or your change history, meaning it will show you when new files have been added, when files have been deleted or otherwise edited, and it gives you the option to revert back to earlier versions of the files if you need to. And there's a lot of different things you can do and ways to accomplish what you want to do. So if you find that you have a question or some sort of specific situation that you want to address, I would definitely recommend starting with the article that's listed here. It's a pretty good intro to Git and RStudio article that I've come across. So we can open up our RStudio project, and we'll go ahead and create a file in this project because I want to show you what it looks like to actually commit changes to an RStudio GitHub project. So right now, just opening up RStudio in the project, and you'll see that in the bottom right-hand corner, we can see the test project.rproj file, so we know that we're in the right directory. And I've created just a simple R script right here. I'm going to call a library and then write some code to do some really simple data cleaning. So once I have that code written and I say that this is the script that I want, I'll go ahead and save it. And I'll save it in the directory that I created when I created this project. And you'll see that that file just appeared down there in the bottom right-hand corner. And you also see that all the files that have been created show up in this Git panel. And this shows basically that the Git software recognizes that some files have been made or that changes have been made to them. So I want to go ahead and save all of these. And to do that, you can just check the boxes right next to all the file names. And then you need to write a commit message, which is basically a short description of changes made, any sort of files added, and you press commit. And just like that, you get a little pop-up box that tells you that you were successful in committing changes to a bunch of different files, and your files have been tracked, just like that. So With these steps completed, we've made our first local Git repository and committed some files to the repo. And in this case, right now, we're looking at the history tab, which will show us the history of the commit that we just made, which kind of gives you a quick overview of the code that you wrote and what changes may have happened. So now that you know simply how to kind of make a Git repository on your computer and how to make some simple changes or commits to that repository, we want to integrate your Git repo with GitHub so that your code can be hosted or accessed via an online website. So just a few notes to talk about GitHub here. Any sort of repos or projects that you put online, they're not going to be public right away. You can make them public or private, meaning that if I make it a public repo, it's not that anyone can make changes to it, but anyone can see it. If it's a private repo, then only you and other collaborators can see what's been written, and obviously no one else can make any sort of edits because they don't even know that your repository exists. So in order to get access to repos within your account without actually going to the GitHub website, you need to get what are called GitHub Personal Access Tokens, or PATs. And you can create multiple PATs if you have multiple computers. And you can revoke them at any time if, for example, you lose a computer or it gets stolen. But you should think of these PATs as passwords. They should never be shared with anyone else. So next I'm going to take you through the steps to create this PAT. And later on, I'll show you what we're going to do with this PAT to make it so that your RStudio/Git project can go up to GitHub. But we're going to go through these first steps of actually creating one. So assuming you've created a GitHub account, you have a page, that's going to be dedicated to whatever you name your account. And you want to go to this top right-hand corner, which kind of lets you get to the settings. And you're going to want to scroll down to the settings button in particular. From there, you scroll to the bottom of the page and go to developer settings, and then go to the personal access tokens button. So go ahead and create one. And the only thing that you're going to need to do is name the repo, and then, name the token, and then select repo. You'll see that there are a ton of different options here of different types of access that you can grant to your personal access token, but you don't need to worry about any of those. So go ahead and generate token, and make sure you copy the token that's been listed below in green, because you'll never be able to see it again. GitHub will never ever allow you to see that token again. So if you lose it, you'll just need to go in and delete the token and create a new one at some point. So, and I've since deleted this PAT, so no one can get access to my account either. So once you've created this PAT, what do you do with it? So the most secure option, at least on a Mac, is to store it in what's called keychain. Some people may be familiar with it, but it's basically like the Mac's inbuilt password storage system. So if I don't know what it is on PCs, but I do know that there is some sort of native inbuilt password storage system. You can go through the same steps essentially on on PCs. So when you store a password in your keychain, they're only accessible if you have the computer password once they've been saved. So that adds a kind of a layer of security, presuming that you're the only person who knows the password for your own computer. And this is going to be the step that follows. You want to make sure that you have the Keyringer package installed. This is used in R to kind of fetch the password from your keychain, which is what we're going to be doing in some of the later steps. So I'm going to go ahead and show you how to add this GitHub PAT to your keychain now. So like I said, you want to make sure that you absolutely have this, this PAT copied. And you can go ahead and search your computer for keychain access. And you want to press the little plus arrow kind of towards the top left. And you'll see that there are several different categories. It doesn't really matter which one you put the GitHub PAT under. So I just put it under all of them. Like I said, you can go to the top left. Make sure you remember the name that you provide. I would say that GitHub PAT is definitely a fine name to go with. The account name doesn't matter as much, but just writing GitHub may be easy to remember. And then paste that password or that PAT into the password space and add it to your keychain. So once you've created a PAT and added it to your keychain, we're just about ready to get our project or Git repository up onto GitHub. So before we go through these next steps, you want to make sure or check that you've actually created a Git repo, that you have some changes that have been tracked, and that this GitHub PAT was created and saved in your keychain, like I said. So there are 2 ways to push your project to GitHub from RStudio, and you can do it at the terminal, or you can use functions from the use this package. I'm not very familiar with using terminal. I'm much more familiar with the use this package and the functions that come with it. So that's the process that I normally go with. And to push your data up to GitHub for the first time, it's as simple as using the function that I've written out here. This use GitHub, you know, some of the arguments that you see within it will tell the function what kind of authentication protocol to use. And you'll see that there's this keyringer decrypt kc pw GitHub PAT call in there. And what that's doing is it's actually accessing my keychain to get the GitHub personal access token that I just created, and we'll use that and send a bunch of information off to GitHub. One thing that I want to note here is that if you need a repository that's going to be private, you should include this function call private equals true to make sure that your repository is made private when you first make it. So I'm going to go ahead and show this on video as well. First, what I'm going to do is just make a couple of extra commits, actually. So you'll see that I'm going to kind of look at the history here real quick. And you'll see that I've made 1 commit already. So I'm going to go ahead and make a few changes to this file. I'm going to call the keyringer package, save this file, and then commit it. So we'll have 2 commits. Like I said, you want to make sure you write a commit message every time before you press commit, and you can close that. And then in this video, I actually decided that I wanted to make another adjustment. So I go ahead and add another package, library, use this. And again, I'll go through the same process of saving the document, checking it, or staging it, which is what's happening when you press that checkbox, and then writing another commit message and committing it. So what I'm just demonstrating here is the fact that you can make a bunch of commits before you actually put your project on GitHub. Whenever you're ready to finally do that, you'll want to run that command that I showed you in the previous slide. So in this case, again, it's the use GitHub function. You want to set the protocol to HTTPS, and then the auth token or authorization token, you'll want to call the keyringer decrypt kcpw function. And again, what this is going to do is pull the GitHub PAT that we put into our keychain earlier. So you'll see that I wrote GitHub PAT demo, which is what I had named the PAT. And when you run that function, it's going to ask you for basically authorization to access the keychain, which is what I was doing there, just typing in my computer password. I'm fine with the project name, which is test project, and there's no description. So I'm going to say, definitely I'm all set. Submit that, and in a couple of seconds, it's going to pop up into a new browser window. And just like that, everything that I've coded in that project is now available on GitHub in a publicly facing repository. It immediately took you to that page, and if I go to my repositories list, you'll see that that test project that I made is now the newest project. So that was an overview of setting up your GitHub repo for the first time, and presumably you'll be working with this repo for a while. And maybe you'll want to continuously make some changes or updates to the repository too. So in order to continuously update your GitHub content, I again find it easiest to use RStudio's IDE for pushing updates. And updates and commit history again can be viewed by clicking on the Git tab. So I'm going to do a quick overview of basically how you make additional updates after doing your first commit to GitHub. So again, I'm going to go ahead and make some changes to this file here. We'll just do a little bit of more data filtering and creating a file actually. So we'll go ahead and filter the iris dataset, which is kind of an inbuilt data set in R that people use pretty frequently. And in this first function call, I'm going to write a CSV. This is just going to show up in my repository. It's just me creating an example of basically a file that we're going to track that isn't a coding file. So you'll see that it appeared over here on the right, and it also showed up in the Git pane on the top right-hand corner as something that hasn't been tracked yet, but Git recognizes that there's a new file. And then we're just going to add some additional code here. In this case, I'm going to do a little more filtering, and then I'm just going to write some code that will create a graph. And we'll have this nice script that does a variety of different things. We're filtering some data, we're reading in, we're writing some data, we're creating graphs, and like that, we'll be all set to save. So you'll see that that also just popped up in the top right hand of the screen. And now that I have these updates to this file, as well as a new Excel file or a CSV, I want to go ahead and stage both of these. And I'll write a commit message that details that I've created a new file and made some updates to this R coding script. And so I've committed it to Git. And this is just on my local computer now. And you'll see that there's now a history of different commits I've made. You can see the previous two that I made, just changing that R script a little bit. And the most recent one, you can see the additional changes that I made, as well as the new CSV file that was made. So once I'm ready, that I've decided that I want to push this to GitHub, you'll see this little message that says I'm ahead of origin, which means that the files on my computer are ahead of the GitHub repo. And when I want to sync everything up, I just go over and press that push button. And you'll see this message that I successfully sent things to the Git repo, the GitHub repo. And so we can double check that by going back over to my GitHub page and going into the test project. And you'll see that there was a commit just a minute ago, and it's the exact same commit that you just saw previously, where I added this new CSV file and a couple of changes to the .r script that I'd written. So there are a couple of additional kind of tips and tricks that I want to give when it comes to managing tracked content. There's this file that's created when you make an RStudio project with Git. There's a .gitignore file in the RStudio viewer pane, and dot files aren't visible in your normal file browser system. The dot prefix will hide the file from viewing it, but in RStudio, the viewer pane, still includes those files. It's kind of a nice little thing that they will include those dot files for you, or the hidden files. And I want to talk about the gitignore one in particular, because it lets you add the name of files that you don't want to be tracked. So this is useful if there are files or subdirectories that you want to keep hidden, from eventually being published on GitHub. So a good example of this would be if you have CSV files that maybe contain patient data, and you will want to, put your code and your data all in one repository or one source file location, but you don't eventually want to put those CSV files up on the internet. So you can add the exact name of the file to the .gitignore file and save it, and it will never track that file. You can also do a little more general approach and say, hey, every single CSV file that I'm going to have in this project is going to have patient data, or it's just not something that I want to put on GitHub eventually. So you can ignore that stuff right at the very beginning if you write this star.csv, and that will ignore all of the CSVs within the entire repository. So what this actually looks like, if you press the .gitignore button, it will open this file here. And in this case, the there are a couple of different things I want to point out. So like I said, you can see the git ignore over here in the files page. The git ignore automatically comes with these first 4 lines written. You don't want to change these. It's good that our data, our history, and everything else is being ignored. The supplemental 5 lines that I've written here, this is part of an actual project that I work on, and there are a couple of different files or types of files that I want to ignore. So in this case, you'll see I have lava files /, and this is a directory of files I've downloaded from Lava. I obviously don't really want those tracked. I don't ever want those to show up on Git or GitHub, so it ignores that entire folder. There are a couple of other files, .rmd and .html, which I don't really care to track either, so I put star.rmd, star.html, and any file that ends with that extension is never going to be included. And then the following 2 lines, 8 and 9, are just 2 more examples of this, where I have a folder called data requests, and there are some subdirectories within data requests. And within all of those, I want to ignore every CSV file and every XLSX file. And so I've saved these preferences into the .gitignore file, and they'll never be tracked, is basically what I'm getting at here. So the other thing that I think that people might want to do sometimes is access their GitHub repositories across computers. So you can do this. There are ways to do multi-computer accessibility for your projects. If one of your computers breaks, you get a new laptop, you switch to a personal computer. You can go through basically the same process that I did earlier of creating a new PAT for every device, adding it to your keychain, and then adding it to your RStudio, kind of using those that use GitHub command. If you want to do it in an easier way, though, RStudio is kind of pre-built with a way to access existing GitHub repositories. And the way to do that is outlined here. You just go start a new RStudio project. Like we did previously, you can click on version control this time, and then Git. And then there will be an option to add the repository URL. In order to do this, you literally just go to the web page of the repository that you want to get access to. You copy that link and then paste it into that space. And there are a couple of other things that RStudio will ask you to specify, but it'll be preferences about where you want this new project to live. You fill that out, and then just like that, everything will be downloaded right to your new computer. So a couple of additional tips and tricks, like I said. Set a folder to be ignored at the beginning of your Git repo creation. So for any sensitive files, I find it easiest to just create a folder called like sensitive ignore, something like that. And that's where all of your maybe sensitive files might live. If you don't feel comfortable doing that, you want to make sure that Git is never anywhere near any sort of files like that. Just put them in a different directory as well. Another thing to know about is that you can set GitHub collaborators on private repos and public repos so that you can share your works in progress. So if you're someone who's coding a big project and you have someone else who wants to help out with some of the analysis or data cleaning on that project, you can work basically on the same project at the same time, and it can stay hidden in a private repository. And there's a way to add collaborators who also have GitHub accounts if you go into the GitHub website, but I'm not going to detail how to do that. I think it's something that's worth Googling to figure out if it's something that suits your needs. And then something else that I'm not going to go into detail here, but there's this really cool function in the use this package called edit our profile. And this opens up another one of those dot files called .r profile. And what it lets you do is preset a bunch of functions or customizations to the project that you're working on. So a good example of this would be presetting a bunch of functions, or sorry, a bunch of packages that you need to load for your project. So if you have a project that has 10 different R scripts and all of them are calling for the tidyverse library, you don't want to write out library tidyverse in 10 different scripts. You just want to add it to your R profile. So anytime you pull up this project, your tidyverse library is going to be loaded automatically. And there are a couple of other like customization examples that you can do in there. it really does save me a lot of time, at least when it comes to writing and kind of headaches and making sure that the kind of the nature of the scripts or the environment of the scripts stays consistent. So this is something that's also worth looking into if you find that you're going to be using RStudio pretty frequently. A couple of additional resources on using Git and RStudio would be what I've put up here. The Happy Git with R is a pretty comprehensive book written by Jenny Bryan that will detail really most of the situations that you would encounter when using RStudio and Git together. The Do More with R, Git and GitHub video by Sharon Mackless is also a really good video. It's a quick 10, 15-minute video that's pretty similar to this, kind of a quick start on how to integrate your Git, GitHub, and RStudio. And then I found that when it comes to Git, at least, just Google is really going to be your best friend. There are really kind of infinite resources on how to use Git and GitHub because it is a standard tool to use across so many different software disciplines, and so many different people will provide you really detailed answers if you have any sort of questions. But with that, I'm going to open up our time now to any sort of additional questions that people here might have today. Again, the video for this presentation is going to be posted on Macipedia and the Mac YouTube channel, and my slides are going to be available at that short link that I've put there, or you can go to GitHub NeuroShepherd, and you'll find the slides in the R presentations folder.